Hey there, we're going to go over our notes on acids and bases. This is our packet page 26, and I have already glued this into my notebook on notebook page 34. So it's important to understand acids and bases because we need to understand the pH scale when it comes to maintaining homeostasis. So when we talk about our pH scale, any liquid that has a pH of almost exactly 7, anywhere from 6.9, 7.1, we would say that it is neutral, right? So water is or has a neutral pH. Any liquids with a pH less than 7 is called an acid. So less than 7, like our saliva, is not necessarily that acidic, but something all the way down at the bottom, like battery acid or the acid in our stomach, has a very high acidic rate compared with our saliva. And then, of course, at the top, liquids with a pH greater than 7, those are called a base. Sometimes we refer to these as alkaline. So that means the same thing, basic or alkaline. And these are going to be things like seawater, baking soda, kind of your cleaning supplies are going to fall on the basic pH. The lower the pH, the more acidic the liquid is, and the higher the pH, the more basic that liquid is. So let's take a look at some examples. Which pH is the strongest acid? So I know that acids are down all the way from 0 to 6. So 0 is the strongest acid. Which pH is the strongest base? So bases or alkalines are on the other side. So that would be all the way up to 14. And which pH is closest to neutral? Well, I know neutral is 7. That's not an option, so I have to pick 6. So there we go. At the bottom, talking about buffers. Buffers are things that help keep the pH of a liquid stable. In the case of buffers in our body, they keep the pH close to neutral. So again, maintaining that homeostasis. So they are important for maintaining homeostasis. That's all we have for our notes for packet page 26, which again I have glued into my notebook on page 34. If you have any other questions or concerns, please let me know. I'll see you next time.